Santa travels fast enough to circle the globe in a night, commands flying reindeer, and carries infinite presents. But his strangest ability is totally different. Squeezing down chimneys that are way too small for him. And the physics Santa must be using to pull this off isn't just weird, it's quantum weird. Let's dive in. I'm Ben. This is Physics or Bust. Chimneys aren't built with Santa in mind. Most are well under 20 inches wide. And the modern ones are often just narrow metal tubes, and Santa is not 20 inches wide. Which means that Santa sliding down a chimney violates classical physics, which means he must be using physics from a deeper reality. We'll explore the 3 physics mechanisms Santa could be using, from the seemingly impossible to the cosmically insane. At the quantum scale, particles don't act like solid marbles. Instead, they act like probability waves. Their location isn't fixed until you measure them. When a quantum wave hits a wall, some of the wave doesn't bounce back. Instead, part of it leaks through to the other side. That leakage becomes a measurable particle that suddenly appears beyond a barrier that it shouldn't have the energy to cross. That's quantum tunneling, and it's real. It's the reason stars can fuse hydrogen, superconductors can work, and even our modern electronics need it. We'll dig into the physics in a minute, but first, if you like this video, you'd probably like this book. I've got a link in the description below. I do get a small commission, but it wouldn't cost you any extra. For Santa to do this, he must be using some technology that quantizes his entire body, changing him from a defined object to a spread out wave function. Then when he reaches the chimney, the wave function presses against the barrier, the brick. And just like an electron, a piece of that probability amplitude appears inside the house. When the wave function collapses, Santa appears inside the house, not outside. Now this isn't Santa squeezing through the chimney. It's Santa existing on both sides, and the universe picking the one that is on the inside. Millions of homes don't have a chimney at all, so how does Santa get in there? Simple. Tunneling works through any barrier, not just chimneys. Bricks, drywall, metal security doors, they're all just potential barriers. If Santa's wave function overlaps the inside of the house, the collapse can place him right into the living room. So if he's using quantum tunneling, Santa doesn't even need an opening. He just needs a non-zero probability of appearing on the other side. You gotta love quantum mechanics, turning breaking and entering into a festive holiday tradition. If you made it this far, remember to like and subscribe, that way you don't miss any of the physics breakdowns we do. The second method Santa could be using focuses on the atoms themselves. Most people have in their minds that objects take up space because atoms are little billiard balls that can't overlap. However, that concept's wrong. Atoms take up space mainly because they must obey the Pauli exclusion principle. No 2 electrons can occupy the same identical quantum state. This rule forces atoms to spread out, gives matter its volume, and is the reason that you're not falling through your chair. So if Santa's using a technology that temporarily disables or bypasses the Pauli exclusion principle, his atoms can pack together far more tightly. He wouldn't be crushed. The atoms don't collapse into neutrons or exotic matter. They just occupy closer states. It's like taking 3D matter and compacting it into a temporarily denser configuration. Santa becomes spatially efficient. Once Santa's volume drops, he can easily fit through a 12-inch flue pipe. And he's not shrinking in the cartoon sense. He's instead turning off the physics that keeps matter from crowding together. I mean, with this technology, you could fit an entire Costco into a carry-on bag. There's some festive physics for you. And the third way Santa could be using involves Einstein's general relativity. In general relativity, space itself isn't rigid. It's flexible, stretchable, even twistable. Black holes curve space. Cosmic inflation stretched the early universe faster than light. Theoretical warp drives compress the space in front and expand the space behind. None of these break the rules of physics, they just require a lot of energy. So instead of shrinking himself, he could stretch the inside of the chimney. To you, it's still a narrow brick tunnel. To Santa, the geometry is manipulated so that the chimney is effectively huge. He slides through as if the chimney is one big metal slide. And this method means that Santa wouldn't need a chimney either. He could open up a tiny geometry bubble anywhere. A flat wall, a locked door, even an apartment balcony. Space bends and Santa just walks on through. All three mechanisms, quantum tunneling, Pauli compression, and space-time distortion, involve energies and quantum effects that would normally obliterate a human body. So Santa must be using tech that is way beyond ours. His suit must maintain quantum coherence, shield against decoherence and thermal noise, stabilize space-time curvature, prevent catastrophic atom collapse, and keep his wave function from spreading into multiple Santas. In other words, Santa's suit is basically a quantum computer, radiation shield, and warp field generator wrapped in cozy red fabric. So which of the three do you think most likely that Santa uses? Tunneling, Pauli, or space-time? Let me know in the comments below. Quantum tunneling and warp field generating can get him into houses without a chimney. Pauli compression lets him fit into those small places. The fact is, the universe is far stranger than our everyday lives suggest. And however he's doing it, Santa isn't breaking the rules of physics, he's just using the lesser-known rules to his advantage. Thanks for watching. The best way you can help this channel grow is to click into this video here. I really appreciate you guys, and I hope that you have a Merry Christmas. And remember, keep asking questions. See you in the next video.